In this lesson, we're going to start using postulates involving points, lines, and planes. So rules that are accepted without proof are called postulates. We learned that a theorem is something that we can prove. So a postulate, we just assume it's true, or not assume, but just know it's true. And again, rules that are proved are called theorems. Postulate and theorems are often written in that conditional form. What is that conditional form again? It's that if-then form that we learned in the last section. If-then. And we learned that converses of definitions, when we flip it, are true, but not necessarily are they true in a postulate or a theorem. So we have 4 postulates that we already learned. We learned about the ruler postulate, measuring with a ruler and finding the length of a segment. Segment addition postulate, where we add 2 segments together, give us the length of the whole thing. Protractor postulate, where we learned how to read a protractor to give the measure of an angle. An angle addition, where we added 2 smaller angles to get a larger angle. Postulates for points, lines, and planes, they are listed here. Through any 2 points, there exists exactly 1 line. A line contains at least 2 points. If 2 lines intersect, their intersection is exactly 1 point. Through any 3 non-collinear points, there exists exactly 1 plane. A plane contains at least 3 non-collinear points. If 2 points lie in a plane, then the line containing them lies in the plane. And if 2 planes intersect, then their intersection is a line. So we're going to identify the postulates that are drawn by the diagrams. So looking at this, state the postulate illustrated by the diagram. So I can see right here that I have 2 lines intersecting. And that their intersection is a point. So if 2 lines intersect, then their intersection is exactly 1 point. Do not write down postulate numbers, even though I know the textbook uses them by postulate number. I don't have them memorized by postulate number, so when you write things down, I won't know what you're writing down. So make sure that you write it out. Looking at this second example, I have 2 planes in the first picture, and the second picture I can see that it's showing me the intersection, that's that line. Okay, so what do I have here? If 2 planes intersect, then their intersection is a line. Okay, so here in example 2, it's going to say identify postulates from a diagram. It wants us to look at this diagram to write examples of postulates 9 and 10. Well, I don't know what 9 and 10 are, so I have to look them up. 9 is a plane at least 3 non-collinear points. And 10, 2 points in a plane, line containing them. I know that's really sloppy, but 2 points in a plane, then line containing them in the plane. Okay, so that's what they are referring to. So now we're going to look at the diagram. We're going to see that we have plane has at least 3 non-collinear points. Okay, well, I can see 3 non-collinear points right here. And what plane are they in? Plane P. So for the first postulate 9, plane contains at least 3 non-collinear points A, B, and C. Postulate 10 refers to 2 points in the plane, the line containing them is in the plane. Okay? So first I would need to find 2 points that have a line going through them. So points A and B. So points A and B lie in plane P. So line, and you can name it AB or N. Containing A and B lie in plane P. Not as much fun trying to write those out. So you do have 2 to try that is still using that diagram that we just looked at in my example 2. Okay? You need to look up the postulates on the first page in order to be able to write examples. Again, I don't know them by number, so you need to make sure that you aren't listing them by number. Okay, so using the diagram, which postulate allows you to say that the intersection of plane P and plane Q is a line? And it's the one that says if 2 planes intersect, then their intersection is a line. It's postulate 11. Okay, postulates 5, 6, and 7. Looking at the first page, postulate 5 is through any 2 points there exists exactly 1 line. So I only have 2 points up there, so it would be line N passes through points A and B. And the postulate 6 is a line contains at least 2 points, so line N contains points A and B. So this is 5, this is 6, and 7 states 2 lines intersect, their intersection is exactly 1 point. So line M and N intersect at point A. And that was 7. Okay, so now we're going to interpret diagrams. And pretty much when you're interpreting a diagram is that you just can't assume information based on what it looks like. It only can be what it is marked. Only what is marked. So you can read through this about the things that you can assume based on the diagram and things that you cannot. You can't, because it looks like you can draw something like G, F, and E. Looks like they would be collinear, but unless a line is drawn through them, they are not collinear. While it looks like I have right angles, unless you have the little red hat, the little red box that indicates perpendicular and right angles, you can't just assume them. Okay, so that is what that pretty much is. So we're going to do some interpretation and drawing based on information that we're given. So, use given information to sketch a diagram. Sketch a diagram showing line TV. Well, how do we draw a line? That's pretty easy. You just draw a line. Since it's named TV, I know I must have the 2 points T and V on it. Intersecting a segment. Okay, so here's a segment P, Q. At point W, there's point W, so that TW and WV are congruent. How do I indicate congruent? I just draw the little tick marks. Okay, so that's how you draw a diagram based on given information. So we know a line is a line perpendicular to a plane if and only if the line intersects the plane at a point and is perpendicular to every line in the plane that intersects at that point. So what that's stating is that I could draw all of these points through this point, all these lines, I'm sorry, through this point in the plane, and line T would be perpendicular to all of them. So if I called this R and that S, T would still be perpendicular to each line that I draw that's through that point. It's still in the plane. Okay? It must be marked with the right angle symbol. So let's interpret some three-dimensional drawings. We have, which of the following statements cannot be assumed from the diagram? So you just go through each one. A, B, and F are collinear. Do we agree with that? Well, I can see A, B, F. They're on the same line, so that is actually true. E, B, and D, E, B, and D are collinear. Is there a line drawn through them? We don't know if they would be collinear because there's no line drawn through them. So this cannot be assumed. So we're going to check that one off. Segment AB is perpendicular to plane S. Well, segment AB is perpendicular to line C. Line C is in plane S, so that would be true. Segment CD is perpendicular to plane T. Well, I don't see any right angles, so that one's not going to work out. We don't know if that's true. And line AF bisects line BC at point B, and that's true. Okay, so we're going to refer back to this example up here that we drew, okay? And it says, if the given information stated that segment PW and QW are congruent, how would you indicate that in the diagram? Okay, so you might want to just redraw that diagram first and then show the indication. And then in number 4, name a pair of supplementary angles in that diagram that you've drawn in 3. So pause the video and try those. So I'm going to redraw my diagram. I pretty much remember what it was. Actually, I lost it up here. I was playing around. I was trying to copy, and I don't know how to copy and explain everything, so I'll just redraw it. And then I'm just going to redraw it down here. So it was line, TV, right, with PQ, intersect at W, and this. So how am I going to indicate that PW and QW are congruent? Well, I already used 1 ticks, so now I use 2 ticks. And name a pair of supplementary angles in the diagram. You could have named anything that formed, any 2 angles that form a linear pair. So it could be angles, oh no, sorry, I'm in red, TW, Q, and QWV. That would have been a pair of supplementary angles. It could have been QWV and VWP. It could have been VWP, and you didn't have to write all of these down, just in PWT, or it could have been PWT and TWQ. So there's actually 4 pairs that will work. For supplementary, it needs to form a linear pair. And then it says, in the diagram in example 4, can you assume plane S intersects plane T at BC? Explain how you know that AB is perpendicular to BC in example 4. So go ahead and try those. In example 4 of the 2 planes S and T, can you assume that plane S intersects plane T at line BC? Yes, you can. It's drawn that way. You can see the intersection. So we'll write yes here. Explain how you know that AB is perpendicular to BC in example 4. Well, we know line AB is perpendicular to the plane S. And we know that AB then has to be perpendicular to every line in plane S. That intersects at point B. Okay, and then closing this lesson, how can you identify postulates from a diagram? And that would be by determining which information you can assume. We cannot assume congruence, perpendicularity. So if things are perpendicular, collinearity, so collinear points you can't assume. Midpoints and bisectors. And then you just determine which postulate applies. And that's the end of 2-4.